is, everybody? Hope you guys are doing well. Okay. Um, when in doubt, just jump. I'm gonna jump right into DOS EMU. I figured out I don't think I need to pull up DOSBox and use that to run too. Okay. Which I'm glad, because some reason why it messes up the recording process and makes it loud, grinding noise. And you guys already got a heart monitor noise. It's not a heart monitor at all. Alright, there's nothing wrong with me. It's something in the computer. Okay. This is DOS EMU. To list out, show where you are, there is a, I'm not going to go over a lot of syntax, but dir will show you where you are. Dir for directory. Okay? Okay. Now, I don't have a heart monitor yet, but I do smoke cigarettes, so I'm guaranteed a heart monitor at some time. So relax. I'm not going to explain too much about what I'm going to do, and I'm not going to do anything super. I'm not going to do anything big. I just want you guys to see some basic, stupid hello world syntax in operation. Okay? And then we'll go over it after I bust it all apart. Okay. Now, so we want to make a directory. We'll call it toot. Okay? CD for change into directory toot. Okay? Dir. Of course there's nothing there. CLS is for clear screen instead of clear. Okay? CLS is to clear the screen. And now we're going to jump open up an editor. Okay? This is the easy way. I will not be doing this very much in the beginning, because it's important to learn the hard way. Okay? And it's not because I'm some sadist or anything, but by learning the hard way like I did, the easy way made a lot of sense. Okay? And the harder way taught me a lot more about what was going on throughout the process of assembly language. Okay? Edit. What do we want to call it? We'll call it tacos. Oh, tukas. Tacos.asm. Okay? Now we're in it. Now, it only takes a couple seconds. We want to say assembler at 100. Okay? Now I like to allocate me a little room here first. And we'll say RCX. Okay? This is going to write 300. Okay? We want to allocate 300 bytes. Okay? And we want to name our code. We want to name it tacos.com. Okay? W for write, new line, and we want to say quit at the end. We could just type Q, alright, but I like to just type out quit, because whatever comes after Q does not get counted. Okay? Let's go back up here to where we started, in the space area, make a little room, and now we want to say move AH register 09. That's an opcode for print to screen. No, that's a string. Okay? And then we want to say move into our DX register, the string location that we want to print. Okay? Then we want to say int for call kernel. Then we want to say int 21 for call kernel, and int 20 for end file, or end the program. Okay? Now, skip a line. I'm going to go down here and I'm going to say assembler at 200. Okay? And at 200 I'm going to say define bytes. You got to put them in single ticks, single quotes, and the bytes I want to say is hey Joe, where are you going with that gun in your hand? Anybody knows that song? Everybody knows that song. Okay? And I want to then say 24. Is this going to work? 24 is a $sign. Okay? We should end it with a $sign, but I like to be funny and end it with a 24. Let's see if that works. Let's hit Control Alt. Okay? That puts us in another mode of our editor. Hit the down arrow. Okay? If we hit down arrow, then we can go ahead and we say save. Okay? Hit Control Alt again. Down arrow to open up the menu panel again, and we'll say exit. Okay, now let's say dir, see if it's stuck. It's there, it's ASM, clear screen. Okay, now we will say debug, debug tacos.asm. No errors, no errors. Clear screen. Now let's see if we can run it. Tacos.com. There you go. Okay? Okay. Now print it out. That's what our program did. That's what it does. Okay? Now, I am going to debug this again. Debugging is not compiling. Or is it compiling? No, it's not really compiling. It's not like you're writing machine code already. So you're writing assembly code. It doesn't really get transformed into machine code. It was read by your BIOS already. Okay? So, and you don't really need to compile assembler. Okay? I could be 100% wrong on this, but it is not in compiling form as we've seen with the C program or with other programming languages. Okay? We can say hello. No. We can say debug taco.com. No. We can say hello. We can say debug ASM, and then we can send it again into something I like to call a log file. So we'll call it taco.log. Okay? Okay, that's done. Now we can edit taco.log and look at it. Okay, great. Now what's going on here is, do I have, yes, I have highlighting, thank God. Right here is the memory address of what we're typing out. Okay, this address 100 was this were these things we typed in here. We said move into the AH register 09. 09 is opcode for string. Okay, and we said now at the 102 space here in memory. Okay, we said move into DX register or data register 200. Okay, 200 is the location of this down here. Okay, we can't move our string, our physical string. We don't move our declared bytes here directly into here, but we move the memory location into this register. Okay, int21 is to call, was to send it to the kernel, call kernel maybe. Do I say that right? Call. No, it's not call. I don't want to say call. But int21 is to call kernel. This is to end the program. Okay. See, our program stopped here. With our new line, then we moved the assembler. We set the assembler at address 200. Now you can see that this address here is at address 200, where our string is located. Okay. Our string is terminated by the $, or our string is terminated by the ASCII representation of the $. No, ASCII is the $. Our string is terminated by the hexadecimal representation of the $. Okay, the hexadecimal representation of the $, is the number 24. Okay, RCX is to put this stuff in the register RCX. Okay, we allocated 300 bytes of memory to the RCX register. We named it taco.com. We wrote it. It wrote 300 bytes. We quit. Okay. Okay. Control Alt again will get you into this little funky panel, which it took me forever to figure out how to get into this little funky panel. Alt exit, and now we'll type in debug. We're in the debugger right now. Let's type in something funky like dump. D for dump. Okay. See, it's the same thing as we saw in hex dump. You have all the same stuff here. This is hexadecimal. Okay. This is the attempt to convert the hexadecimal. Okay. Now let's say quit. Now let's say debug our program, which was hello, or no, taco.com dump. Okay. That did not work out very well because I don't think I did that properly. Quit, clear screen. Let's say debug taco.com dump. Did it again. The problem with emulators sometimes is they get a little sticky. Okay, it's no biggie, but we'll try to debug something else. Debug taco.asm. Okay, now we're in the debug mode. Let's hit D for dump it out. Okay, so you can see here there's this is, let's do this. Let's say dump, let's say R now, down here in the debug mode for registers. Alright, this is a step-by-step on how your program executes, and I'll go over everything you see in a few seconds. If you remember, in my code, I set the assembler to 100, okay? Or basically, this is just saying address 100, okay? So you can see here that this got changed to 100, okay? The certain areas here, this is delimited, separated by a colon, okay? This first area over here is called the code segment, okay? Down here is the parts of your processor, and this is going to show you what you're doing as it executes in progression and everything else. Now let me see if I can actually hit T for step-by-step execution. Yes, I can. That is great. T 98 T. Okay. After a while, it'll just get monotonous looking, and it goes into some other form of nature. Okay. I hit Q for quit for that. Clear screen again, and we're going to go back up to our debug taco.asm. Let's print out D for dump. We're dumping the source code of our file right now. Alright. Hit R to dump out, to see what's in your registers. That's what the R stands for. Okay. Okay. This here, this selected area here, okay, is called the code segment. You can see here that the code segment is pointing to, this is your address, memory address, okay? This here is called the data segment, okay? This is where your data is located. If you notice here, 61 all the way to 30, okay? Remember what I said before about the hexadecimal flip over, okay? Standardly, we read things from 0 to 10. Here's 0, 10, okay? Another increment of 10, okay? When hexadecimal, 10 is not the number 10, but 10 is a full 16, okay? So now if you look here, you will see that you have 1, 2, 3, 4, 5, 6, 7, 8. This slash sign here indicates the other 8, okay? So 8 double is 16. This is working out fine. Okay, so that's what's going on there. These are your registers. These are the parts of your processor. This is a 16-bit processor emulator, okay? That's why there is no EAX, but there is just a AX, okay? There is no EBX, but there is a BX, okay? There is no ECX for extended CX register. There is just a flat CX, okay? Because this is working on a 16-bit principle. DOS was a 16-bit operating system. And that's it, okay? These are the parts of your processor or boxes. Like I said before, these are your registers. The AX, BX, CX, and DX registers. This is a stack pointer. This is a base pointer. This is a stack instruction, I think. The data instruction, I'm probably wrong on those two. Okay, data segment, the extended segment register, the SS register or stack segment register. Okay, code segment register. I don't know if that's a register, but that's where the code segment is pointed to. I think it is a register. I don't see why it wouldn't be. Okay, and the instruction pointer here. Okay, This is a register. These all down here are flags. They all mean something, and I did figure out what those meant, but I don't remember enough to tell you what they meant. Okay? This is your physical processor. If you have a physical machine, I have a virtual machine right now, so this is not physically the processor. But if this was only running DOS, this would be my physical processor, my physical architecture, the physical blocks of my processor that I can write stuff to. Okay? Okay. You can see here, this all comes out here just as it was in the hex dump mode that we had. It attempted to convert what these ASCII characters are. Okay, 61 is an A. Okay, the number 100, or as you see here, space, the space bar is at number 20 in hexadecimal format. Okay, that's that. Number 31, our numbers begin at 30. Okay, our numbers begin at 30. Okay, so 0, if our numbers begin with 0, okay, 0 through 9, 0 is number 30. 31 is our number 1. Okay, here's a 0 again. OD is a new line. Is it OD or OA? I think A might be a line. OD is new line. Okay, so OD, as you can, I hit the enter key, which put me on a new line. Okay, OA I think is the alignment of it. Okay, you should use these both in combination whenever you want to type out something in a new line. Okay, 6D is hex for move, or M as in Michael. Okay, 6F is the letter lowercase o. Okay, it's not an uppercase O. There's a difference for an uppercase O in hexadecimal. Okay, V as in Victor is 7-6. Okay, okay. Am I right with that? Yeah, I'm right with that. Okay, and then as you remember, I typed in a space. Okay, and AH register. Okay, comma was 2C, space 30 for 0, 9. 39 is 9. Okay, new line ODOA. Okay, that's what I did, and that's what you get on the other side here. Okay, you can see here that our program, that's our program. This is how our program looks. Okay, let's see if I can say T again. Can I say step-by-step execution with T? No, I can't. Let's say quit. Okay, let's say clear. And now let's bring it up again. Debugtaco.com. See what happens. Okay, let's say D for dump, and something happened that I'm not sure about. It doesn't happen that way on my other machine. Okay, let's say quit. Let's say clear screen again, and now we will say debug. Debugtaco.asm. Okay, you can do that. Enter. D for dump it out. Okay, back where we began before. Is it T? Right now I'm going to go on a tangent and go experiment. I'm trying to figure out, there's step-by-step execution that you can show, and it should have been T. It's not R. It's not L. Not I. Oh god, it's not I. A. Yeah. Okay. Quit. Clear. Okay? Sometimes, if I restart it, I'll run into an issue. But that's what it looks like. That's where I'm going to cut the video off. And I'm going to figure out exactly what it is to show step-by-step execution, so you can actually see things being stuck in the processor and moved from parts of the processor to the other part. Okay? So, get this program if you don't have it. It's called DOS EMU. Okay? And the reason why I'm using DOS EMU is because it comes with a debug. Okay? DOSBox does not debug. Okay, DOSBox does not come with debug. Debug is a program. Okay, and it's just an interface for us to enter machine code. Okay, because you can't really just enter machine code anywhere. Well, I'm not that smart. Okay, but I do know you can access it through debug. Alright, so I'll pick it up on the next one after I figure out why I can't do step-by-step execution, because I want to show you pieces of data moving through the processor itself. Alright, so with that, party people, shortest tutorial ever. Can you believe it? It's gotta be under 10 minutes. It's gotta be. It's just gotta be. 48.95. Kill. 48.95. Have a great day.